This is semester 1 final practice number 3, also chapter 6 practice. So this is the ping pong ball problem. We've got a ping pong ball, it has a speed of 25 meters per second, then it hits the wall and bounces off with a speed of 17 meters per second in the opposite direction. I want to find the change in momentum of the ball and the average force exerted on the ball. So, before it hits the wall, let's do the wall here. Ping pong ball is coming in with a speed of 25 meters per second. And then afterwards, so that's before. And then afterwards, it hits the wall exerts a force on it, and the ball heads back the other way. Okay, and it heads back the other way with a speed of 17 meters per second. And the mass is 0.008 kilograms, because it's a ping pong ball. Okay. Alrighty. First I want to know the change in momentum of the ball. Well, change in momentum is simply initial momentum minus final momentum, or other way, sorry, final momentum minus initial momentum, which is the same as mass times final velocity minus initial velocity. Okay, so for this ping pong ball, that is mass, final velocity, well, these are opposite directions. One of them has to be negative. It is up to you which one you want it to be. I'm going to choose the after because the way I drew it, that's left, and I'm comfortable with left being negative. So final would be negative 17 meters per second minus initial is 25 meters per second, positive 25, so minus a positive. Okay, and that gives us 0.008 times negative 42 meters per second. So in the end, the change in momentum is, put in my calculator, 0.336 Newton seconds, or kilogram meters per second, whichever one you like. Okay, that's part A. Part B, I want the average force exerted on the ball if the impact took 0.090 seconds. I need a little more room here. Okay, so I know that change momentum is the same as F average times delta T, which means the average force exerted on that ball would have been the change in momentum over the change in time, which in this case is, here's my change in momentum, so I just put that in, 0.336 Newton seconds over 0.090 seconds. It was 0.090, right? Yeah, okay. Okay, put that in the calculator. I conveniently still have the last answer in my calculator. And we get 3.73 newtons. Whoa, that's not a 7. Okay, let's talk about points. Let's spread these out a little bit. So let's do one each for each answer, one for each set of units. Something like that. How about one for each equation? By the way, this one, like, it could be delta P equals PF minus PI. It could be M times the change in V. It could be MVF minus MVI. Pretty much any expression that you're finding the change is fine. Then let's do a point for plugging things in the proper places. You know what? If you don't do this, but just jump straight to what the change is, that's fine as well. Either one is fine. What I don't want to see is you putting, like, all of a sudden this answer just appears out of nowhere. Like, I don't want you to go directly from here to here, because I don't know where that came from. Or heck, if you just left this and then just this answer was just sitting here all by itself, that would be a little weird. Then we need a point for plugging in the time correctly. I think that's 10 actually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is 10. Okay, that's it then.